Hello everyone, my name is B. Satyasa Venkateswarlu. My ID number is 20000301006. I am the peer mentor for data visualization techniques. Today my video log topic is the non-spatial visualization. Non-spatial data is also an attribute or characteristic is that all the information which is independent in all the geometric locations. For example, a person of height, mass and weight are non-spatial because they are independent of the person's location, because there are many types of data to the person, to a certain person. Here data are typically non-spatial in the volume of data. Population information for specific locations can say city, district or provinces or state, etc. The population through is non-spatial data type having relationship with locations. Here data types are many useful for it. And the next one is there are two types of data, non-spatial data and spatial data. Today my topic is all about non-spatial data only. There are 6 types of non-spatial data. There are nominal, ordinal, interval, ratio, cyclic, amounts and counts. And there are 6 types of attributes in this. They are nominal, ordinal, nominal or ordinal, categorical, interval and ratio, cyclic and counts and amounts. The measurements are like this. For nominal, the examples are martial status, sex, gender, ethnicity, etc. For ordinal is student letter grade and rankings in the class or in any place. Intervals, the temperature in Fahrenheit scale, Celsius scale and Kelvin scale, etc. Ratio, we have ratio on age, height, weight, etc. And the first one is nominal data. Nominal also can be known under name as categorical data. Nominal is the simplest form of the attribute data. It is described by the name and to identify or distinguish between one of them. Now for another with no specific order. In nominal attribute we does not have the specific order. For example, we have letters, numbers, colors, etc. Now, how to analyze nominal data? Nominal data can be analyzed with which of the following variables can be grouped together categories. For each category, frequency or percentage can be calculated. The data can also be present visually, such as pie chart or bar chart. And these are the examples for the nominal data. And there are the graphical techniques to analyze the nominal data or graphical data, that is bar chart and pie chart. Bar chart is used for the nominal data and we can show our data in our respective bars. So we can see that up and down bars, because the children who are having more attraction on the color has high level bar, and the small is less people like the pink color. This is all about bar chart. And next one is pie chart. Nominal data can be also visualized in the form of pie chart. In the pie chart we can show many examples, like this is the example, and most of the one has completed their 50% of the people has completed their color typing, and the other one less than is 7%. Like this we can visualize the bar chart using the nominal data. And the second one is ordinal data. This act of prioritizing nominal categories transforms nominal level of measurement to ordinal level, but not ordinal level to nominal level, because the properties or categories cannot be based upon a numerical value, such as the indication of the order or importance. Ordinal data are also considered to be categorical, means it is qualitative, means we can see the quality of the data which is given from the data set. Ordinal data are type of data in which the values flow in natural order or sequence, means if the ordinal data has a sequence, it's like for example like 1 2 3 ranks, this is the sequence, and this is the example like attribute and values. For attribute, cancer detected is yes, result is pass or fail. Like this we can show the ordinal data. And our next third one is interval data. Interval data always appears in the form of numbers or numerical values which are can be shown the distance between the two numbers in a standardized or equal. For example, interval data has included temperature and year. With interval data, the 0 point is, but this is the example. Examples of interval data can be included the temperature and year also. With interval level of data, we can show that the 0 is the arbitrary constant in the measurement scale. For instance, 0 degrees Fahrenheit scale is have been used. We can show that this is the properties of example, like we have the three scales: Fahrenheit scale, Celsius scale, Kelvin scale, etc. In Celsius scale, degrees of different temperatures. In Celsius scale, we can show many types of temperatures, and this is all about interval data. And the fourth one is ratio level data. Ratio level data is also defined as quantitative attributes of the same characteristics as interval variables, but in additional this we have zero or sorting points. It can be measurable continuous interval data to classify the rank data. And for example, weight in the ratio, because it makes the sense to say that the person 100 kg is twice than the heavy of the percentage of 50 kg. But Celsius temperature is only interval between 20 is not twice as hot of the 10. Now this is all about the ratio level data. And the next fifth one is cyclic. Cyclic means it will have the circle structure. In GIS, it is sometimes necessary to deal with that the direction cyclic or including the degrees of a map or compass, where the data consisting of directions or times in which the measurement scale is after 23.59 comes 00 after 359 degrees, etc. This is somewhat analogous. This means in the cyclic direction we can show that the compass is rotating in the cyclic direction. This is all and this is the example for the cyclic data. And our next one is sixth one is counts and amounts. Counts and amounts show total numbers. A count is the actual number of features on the map. An amount of quantity that can be measurable quantity associated with a feature. That means feature on the map can be shown as a count. Any measurable number connected to a feature of the count. For example, the total number of students or pupils in a class is counts and amounts. We can show the graphical representation of counts and amounts data. For counts data, we can show the bar graph, and in amount data, we can show the table graph, that is in Excel sheet. In bar graph, we can see that the day by day or year by year, the bar graph is slightly increasing to the highest level of the data. And the amount data has many things like product, arrogant and status. And the Himachal Pradesh district wise population, and we can see that most of the green is covered with Kailan and Kalpa, and the HP districts have 91 census sheet. And this is all about the counts and amounts. And the conclusion: non-spatial data are stored in GIS as tables, such as attributes of the given tables. A non-spatial visualization can be represented or visualized like bar chart or pie chart, etc. And we can show in the form of like rows or columns, etc. Each row or column can be represented as a one characteristic. And this is all about non-spatial data. Non-spatial data is somewhat opposite of the spatial data. Non-spatial data has these are the 6 types like nominal, ordinal, interval, ratio, cyclic and counts and amounts. And this is all about the non-spatial data visualization. Thank you.